It is a true fact that anytime you have a continuous function on a closed bounded interval, that function will always achieve a maximum and a minimum somewhere in that range. Now, if the maximum or the min occurs at one of the endpoints, great. But what if it occurs somewhere on the inside? Well, here's a cool generalization of what we know before using derivatives. In fact, we don't even need to assume that that function is continuous on our interval. In fact, let's just take any old function defined on the open interval from a to b. If that function achieves a maximum at some point in that open interval, then I can tell you definitely at that point, either the derivative doesn't exist or it does exist and it's equal to 0. Points with this property are often called critical points, and this theorem is sometimes called Fermat's theorem and other times just called the critical point theorem. In fact, this is what we use all the time in Calc 1 to actually solve optimization problems. This is because what we can quite easily do for lots of functions is find critical points by using it. Then after that algebra is done, we can check the endpoints, look at all the values of our function at all of these points, and find the max and the min. Fermat's theorem is what helps us really make rigorous that technique we learn in a calculus class. And the proof of it is not so bad, although it's a little bit technical, but let me tell you the idea of it. So suppose you have some maximum in your open interval, say maybe somewhere near the middle. Well, if the derivative doesn't exist at that point, we're done. But if it does exist, we've got to show that the derivative is 0. And we'll do that by contradiction. So suppose that the derivative was non-zero. Let's say it was positive, and so it's going up this way. We've got kind of a tangent line that should be pointing in this direction. Well, that should kind of indicate that if we move just a little bit to the right, our function should be a little bit higher than this supposed maximum we had. And you can do all of that just using the definition of the derivative and a little bit of epsilons and deltas. It's really at this part of the course where all of our intuition really starts to pay off, because we start to see like how using epsilons and delta is just like second nature to us. In the next video, we will talk about the mean value theorem.